Thermal throttling explained. Why your smartphone slows down when it gets hot. The necessity of thermal throttling. Thermal throttling is a built-in, automated protection feature present in all modern electronic devices, including smartphones. Its sole purpose is to reduce performance, slow down the CPU and GPU, when the internal temperature of the device exceeds a safe limit. This is not a malfunction, it is a vital defensive mechanism. Without throttling, the sustained, excessive heat generated by the processor could permanently damage delicate internal components, melt internal solder points, or, in extreme cases, warp the device or cause a safety risk to the user. The causes: processor overload and environment. The primary cause of thermal throttling is the intensive workload placed on the system on a chip, SoC, which consumes more power and generates heat as a byproduct of work. Common activities that trigger this include playing graphically demanding mobile games for extended periods, recording high-resolution video, like 4K or 8K, or using GPS navigation outdoors in direct sunlight. High ambient temperatures, like leaving your phone on a car dashboard, significantly exacerbate the issue, as the phone reaches its thermal limit faster. The automatic response, scaling back. Sensors embedded throughout the phone's hardware constantly monitor the internal temperature. When these readings cross a manufacturer-set threshold, often between 45 degrees centigrade and 50 degrees centigrade on the surface, the operating system immediately intervenes. Involves dynamic frequency scaling, DFS. This intervention involves dynamic frequency scaling, DFS, where the processor's clock speeds, frequency, are drastically reduced, and the voltage supplied to the chip is lowered. By reducing the power consumption, the SoC works less hard, allowing it to cool down naturally. The user experience of throttling. The symptoms of thermal throttling are immediately apparent to the user, particularly during heavy use. You will notice reduced gaming frame rates. Games that started smoothly at 60 FPS may suddenly drop to 40 FPS or less, causing noticeable lag and choppiness. Sluggish app performance. Apps take longer to open, and switching between them feels slow or unresponsive. Dimmed screen. To save power and reduce heat from the display panel itself, the phone's operating system may automatically dim the screen brightness. Device heating. The phone will feel noticeably warm or hot, usually concentrated around the camera processor area. The passive cooling challenge. Unlike desktop computers and gaming laptops, which use active cooling like fans, smartphones must rely almost entirely on passive cooling. This involves internal components like graphite sheets, copper heat pipes, or vapor chambers that simply spread the heat away from the processor to the metal frame or back panel, allowing it to dissipate slowly into the surrounding air. The small, sealed nature of the smartphone chassis makes efficient, sustained cooling extremely difficult. Tips to mitigate throttling. While you cannot disable thermal throttling, it's a necessary safety feature. You can take steps to manage heat and maintain peak performance for longer. Remove the case. During intense gaming or charging, a thick protective case can trap heat. Removing it allows the phone's body to act as a more efficient heat sink. Avoid charging and gaming. Simultaneously charging, which generates heat, and performing a heavy task, which also generates heat, creates a rapid thermal spike. Cool the environment. Avoid using your phone in direct sunlight or in a hot car. Play demanding games in a cool room. Close background apps. Minimize unnecessary background activity to reduce the overall workload on the CPU and GPU. Conclusion: by understanding that thermal throttling is your phone protecting itself, you can adjust your usage habits to keep the powerful hardware running optimally for the longest possible time.